only paying for the same shipping as it would be for two of them.
Or like the variable resistor kit comes with like 200 freaking variable resistors.
That-
Like, what
yes.
am I gonna do with that
Exactly.
many?
Yeah,
I've got spares.
Yeah, I think that's.
Has anybody started or finished the Joule Thief?
I started it.
Started.
How far did you get?
I was doing layout, and then I was like, oh shoot, I'm supposed to do LT Spice first.
You're breadboarding it first?
I tried making my transformer, and right when I finished wrapping it the 30th time, I pulled too hard and snapped.
Nice. Don't do that.
I tried simulating the 9-volt battery, and I couldn't get a combination to work.
So the problem with the 9-volt battery is that that's the point of the Joule Thief in this application is to light a 2.8 volt LED with a 1.5 volt battery. With normal DC, you couldn't do that, right? There's not enough forward voltage through the diode. So our trick is we're going to store up some energy in this transformer, which is what's running right now on this demo, and we're going to flash that LED instead, and we're going to charge up, and then it's going to dump that current and charge it and dump it, charge it and dump it, and that's all it's doing. But if you have a 9-volt battery, it shouldn't work at all because it should have enough to just power it. It just goes. There's no charge and dump. It's just all dump.
It was all done.
Yes. So if you really want to use a 9-volt, get yourself a bunch in series and step that voltage up, something like that.
Wait, 9.
He was playing with 9 volts. But
Why would you do a 9
yeah,
volt for this project? Is that-
because he felt like it.
I just thought it was.
Yeah, no, it's fine.
If
So
anyone's
the-
available at 1 p.m. tomorrow, I'm gonna be making it in the capstone lab. Everyone's in. Everyone's welcome.
One thing to note, and it's on the diagram, and I made a point to put it on. Is anybody not in the Discord for the ECE Circuit Lounge?
For this class, so.
I don't know how to.
Just in general, this class is part of that Discord.
Is that, sorry, I'm trying to get it on the Discord. Is that different than is it the PSU ECE tutoring one? or-
No,
No.
she's called Circuit Lounge.
Yeah.
If you're not, come see me. I'll add you. Somehow I wound up being an admin on that Discord for my student time.
Thank you.
It's not required for this class. It's just a helpful resource. But in our class channel, I'm trying to speak slowly. I've got you guys in mind. In our class channel for the Discord, I posted another diagram for the Joule Thief. Yes.
Yeah.
One thing to note, if you weren't paying attention on the Canvas one, it's that means there's a core, 2 lines. Everybody agrees that's a transformer, right? But it's marked like this with these dots. Now the dots are kind of up to you what they mean and sort of context based. But for what I like to do, this is my toroid, and I've got blue wire. I've got one blue wire that's going over, I've got one that's going under the toroid, right? When you look down on it. I'm gonna have the same thing for green.
Which one's coming up and which one's?
Which one's coming up? It doesn't matter which you pick, but if I say that my dots are the ones coming over, then that means that applies to both of them.
Right, so.
So if you switch this up, it won't work.
Why? Okay, so I was.
Because the voltage is inverting. When I run a current through this, it induces a voltage in this, but depending on which way this is wound, it depends on the polarity of that voltage. in the
Wait,
transformer.
okay, so if I basically had them both going the same way.
Well, normally you would wrap it this way. You would just, like some people, Jasmine had a great example. If you take the magnet wire, that little bright colored wire that's in your kit, and you just fold it in half and wrap them both through and then just cut it, then you sort of have 2 windings, right? It's the same thing. That's actually a really good way to wrap.
Yeah.
It's a good way to wrap an inductor. So all she has to do, she just cut it in half. All she has to do is cut the wire here, and then she's got 2 windings.
That's very clean.
Right? That's a clever way to do it. One thing with this stuff, you can't really see it because she's got the clear enamel, but you can see it better on, I've got red.
Red one.
I've got a little thinner wire. You see how it's red? This is copper wire. Copper's not red, right? So this has an enamel. You have to scrape it off, especially if you're trying to solder to it or connect electrically to it. This stuff is intended for wrapping motors and wrapping things. So if the wire happens to touch itself, you don't want it to short out. right? So they they coat it. But then if you want to electrically coat to, or connect to, let's say the end of the wire to connect to your circuit, you need to scrape that off. A little bit of sandpaper, I used to just carry like some 120 grit sandpaper, and you can just kind of, and it'll come off. And if you've got the red, you can see it really well. This you can too, it becomes a little shinier. The copper underneath is a little brighter, but this is kind of like an orange enamel coating, which is harder to see. Part of this assignment isn't because the Joule Thief is like some miracle kick-ass circuit that is crucial to your understanding of analog electronics. It's, let's get on the same page of building stuff. Here's a transformer, here's some basic stuff you'll run into. So there's nothing, there's not gonna be a quiz or anything about the Joule Thief. This is just a, hey, build this cool thing. You'll know it works because the light comes on. One thing I do want to show you today, I'm going to talk about LT Spice quite a bit. Who has never touched LT Spice? Who is not comfortable with LT Spice? There's more than that, but that's fine.
Do you have access to this?
We're going to talk about LT Spice a bunch today. For one, it's really cool. It's a free program. You can get it anywhere. You can use it commercially. It's one of the few programs you can download for free and use it in your job. And the reason for that is a company called Linear Technologies, which is what the LT and LT Spice stands for, wanted to sell their components. And there is a program called P-Spice, and there's H-Spice also, which is out there. We just kind of colloquially call those Spice. It's the name of the language that you draw these in. It's an expensive tool. Well, LT Spice said, well, what if instead of having a model for every single component, you usually have to write your own models. What if we have our software guys write models for only our products? And then we can have so-and-so at Intel and so-and-so at Qorvo, and oh, I need a voltage regulator. Oh, I don't have the model. Well, I'll just use the LT model. Which part do you think is gonna wind up in their hardware? We already simulated the one and we have to make a model for it. So it's really just a giant advertisement for Linear Technologies, which is funny. But it is a very effective tool. It's been around for decades. Spice in itself is the same no matter which product you use, but LT Spice is free and you can use it commercially. A lot of our software that we have at Portland State, ADS is a great example. You guys all have access to Advanced Design System from Keysight, which is another amazing tool. And I can say that because I'm not on the clock, they're our competitor, but it is an awesome tool. I learned how to use it in microwaves, which is the best class in the program. And you can't use that if you're a student. You can't take that to work and use it. You will get either PSU in trouble, or you might get fired because you're using software that you're not supposed to use at work. You don't have the license for it. LT Spice is not in that category. You can use it for free because they want to sell to whoever you work for, no matter what. It's for hobbyists. It's one of the cooler tools you can use because it's got so much versatility to it. What I'm showing on screen now is something. Oh. What I'm showing on screen here is a laptop program. Now this isn't Spice because these aren't. This is something I have. You can't see it. It sucks. This is a 1.2K resistor. I've got a BJT. It's just an NPN. Is it a 3904? No. It's just a BJT. This is just an LED. I can set a few things to it, but it doesn't represent any real parts. This is great for this kind of description, and I'll sometimes play with this, and it's great for showing off some basic electronic circuits, but it's not great for building stuff as a prototype because this is fiction. Like this transformer doesn't really exist. It's just, I think, 100.
How did you get it? I've used LT Spice before. I didn't realize you could get it actually.
This is not LT Spice.
Oh.
This is an iPhone app. Sorry, an iPad app. I am pulling up my work computer now, which I would have done before, but I really needed this Gatorade before class. Battery is probably dead. So. Has anybody not picked up the lab kit? Okay. But you started working on it anyway because you already had some of the stuff?
I didn't realize that, yeah, basically.
Okay, that's fine. You've already started working on it. I just want to make sure there was nobody that didn't at least pick up the kit. That's good to see. I'm going to show you Spice on my work computer because that's what I got it installed on. They don't let you install anything on the PSU machine, so I was really surprised by that. Again, I apologize for the wants to read my email. Go away, go away, go away.
Of course, Genius.
I know. All right, so here's LT Spice. And no, so it'll update your definitions. Let's say LT Spice is like, hey, we added some new models in. Do you want to update? I don't really care. I'm not going to use them right now. So to start a new one, I think I made this presentation friendly, so hopefully these work. But basic commands, R, L, and C. R puts the resistor down, so I have a resistor on my cursor, I can slap it down, it automatically increments my reference resistor. I can go C, I can type L, those are your basic ones. D is diode. If you forget these, F2, which is really the answer to everything, and you can put everything down. So I've got a current source, I've got a diode, I've got 2 different types of inductors. I've got a PMOS that doesn't have the body diode connected. I've got a Schottky diode. I've got all these kind of things. So I'm going to connect all these parts together. So let's just build something real dumb. Let's just build some RC thing. So I'm going to do that. And I want to put a voltage source down. So then I hit F2 and I can go to voltage. Okay. If I want to connect these things, I can either draw it with this button here, wire, or if I hit F3, I get this crosshair, and I can connect them. What's really cool about the connect tool is I don't have to, if I click, it lets me change angles, but I can go all the way through this, and it understands that I need to connect them all in series, which is sort of useful. Right-clicking on something, let's say I want this to be a 5-volt voltage source. I would right-click here and say 5. That's 5 volts now. And that's 100K. And if I type 100 nano, it knows I mean nanofarads. If you type 100 U or 1 UF, it changes it to micro, to the mu. It knows what you mean, which is kind of nice. Okay. G is ground. You always have to have a ground in LT Spice. And I could run this and charge up this capacitor, and it would be really boring. But to run something, I hit run, and if I don't have a command, it asks me what kind of simulation do I want to run. So a transient is a time domain simulation. So let's start there. Let's stop this at 1 microsecond. And I'm going to start saving at 0 seconds, and I'm going to start my DC supply at 0. So it's not going to be 5 volts from all eternity. It's going to simulate as if my 5-volt supply suddenly turned on. And then I hit OK. And then I get a plot. And I can cross probe, which is a term. I can cross probe, and I can, if I hover over this, you see I get a little like oscilloscope probe as a mouse cursor, and I can see what the voltage is at this point. And I'm actually going to simulate this a little longer because that isn't enough time. So I'm going to change that to 50. Okay, so that's our 5-volt rail turning on. It turns on in 20 microseconds. But if I measure what the voltage is at this capacitor, I get nothing because this is probably a bad example because I've got 100. Let's change this resistor value down to 100 ohms. Let's charge this cap a little faster. And let's charge it a little faster. You can see how fast this runs. So I'm charging this capacitor to 5 volts, right? There's some advanced commands. Let's say I wanted to run this as an AC signal. If I right-click on the 5, I can change this to 5. But if I right-click on the voltage itself, I get this menu, and I can say, oh, this has series resistance 50 ohms or 0.1 ohms or whatever. And if I go advanced, I now can do a sine wave, a pulse, a square wave. I can input a file if I want. If I recorded a file, I can import, let's say, the intro to Star Wars and play it as a voltage, as a sound file for my computer if I want. If I'm doing a AC analysis, I might give this an amplitude of 1. So when I do an AC sweep in the frequency domain, I can see how this circuit behaves in the frequency domain. So if I want to do that, I'm not going to run a transient analysis, I'm going to run an AC analysis. And this says sweep across all frequencies. I'll tell you where to start and stop the frequencies. I'm going to run this as a decade sweep, and I want there to be 1,001 points per decade. What's a decade? 1 hertz to 10 hertz is a decade. 10 to 100, 100 to 1,000, 1K to 10K. Those are all decades. So in every decade of frequency, I want there to be 1,001 measurement points. So I'm going to say my start frequency is, let's say 1K to 100K. Yeah, let's just go 100. 10 to 100K. And then when I run this, I see, hey, I made a low pass filter, no surprise. And if I click on the trace name, I get, you can see I've got fade, I've got magnitude and phase, it's just the Bode plot. And I can drag my cursor down and see, oh, where's my 3 dB point? And I can see it down there on the bottom right. That's about 3, right down here, right? And I can tell what frequency that happens at, which is 15.9 kilohertz for this RC filter. This stuff is super useful. I'm going to show you lots of tricks. This is super, super basic. There is, or there was anyway, I'm not sure if it's still around, there's a Yahoo user group, I should tell you how old it is, on LT-Spice, and they can make a world of difference. They're very welcoming to new people. The LT-Spice community is very friendly. There's a Spice model for most things. It's mostly for passive devices, so they do have, for example, a 555 timer. If I hit F2, I can go into some of these categories. I think it's under miscellaneous. And there's an NE 555 timer. And I can put that down. And if I have a 555 timer schematic that I want to build, some oscillator of some kind, I can use that. But most ICs aren't going to be in here. So let's say you have a MPQ 30nano4, it's the matched pair transistors. That's not in this. You need to put it down as multiple transistors. That said, let's say I've got an NPN and I want to put it down. It already has a bunch of models built in for you. So if I right click on it and say pick new transistor, hey look, there's 30nano4 right there. That's the model. So if I'm building a circuit that's got 30nano4s in it, I can change it to that. Same with diodes. I can put a diode down, any old diode, and I can go pick new diode, and I can sort by type. It's bigger.
Sorry, what did you click on to get the diode?
Oh, D for diode, D.
Oh.
Yeah, sorry, I rocketed through that. Fancy. D, R's for resistor, L's for inductor, C's for capacitor. There's a bunch of shortcuts. F9 is undo. I don't know why F9. But if we right click on an active component, a diode, transistor, I can pick a new one and I can search for what type of part it is. So there's silicon diodes, which are just generic ones. I've got Zehners. Somewhere I've got a small collection of Schottkys. Yeah, there's Schottkys, and then there's LEDs and a couple other specialized ones. It doesn't have everything, but it does have some basics. And I think most of the things we do in this class are either going to be in Spice, or I will flat out just give you the model. Part of your final is in Spice. You'll have to import models. If you're new to Spice, we will spend the next 12 weeks in it. So none of it is hard. It's very, very simple once you get the hang of it and play with it. Yeah.
Did you use a blue LED when you modeled this for the Joule Thief? Which blue LED did you use on that diode list?
Actually, I did. I modeled it because it works with pretty much anything. I use my iOS app.
Okay.
But you need to find an LED. I don't have a model for it, but you can go dig one up. Your LED has a forward voltage of 2.8 volts, and it should be a 20 milliamp LED. So if you exceed 20 milliamps, you risk burning it out. which really means if you put too much voltage on it, then more than that current goes through and it burns out, but
How much current?
20
20
milliamps,
million.
which is common.
Yeah, it's very.
20 is like your boring generic. So if you, is everybody comfortable with this? Okay, you wanna see something cooler? You can build a VNA. Anybody not used to VNA? Cool, you can build a VNA in Spice. I'm not sure if I've got it built here, but I can build it really fast.
Could you remind us what a VNA stands for?
Vector Network Analyzer.
Oh.
Thank you for asking, I appreciate it. No, I don't have it built, okay. So because of the way math works, and the way you can do things in Spice, we can build a VNA. And what a VNA is going to do for us is it lets us build, let's say, filters, which is what you're gonna do in the second half of this term. You can build a whole filter and then check what its impedance is at those responses and see what your S11, your return loss is at those frequencies. And you don't need a piece of super expensive software like ADS or HFSS or Clarity or Sigrity. All these other tools cost thousands, tens of thousands of dollars to get access to. You can get a pretty fair approximation of that math in Spice, provided you put enough of the model in. So for that, we're gonna put in a voltage source, and I'm gonna put another one in, and I'll explain what I'm doing here. So I've got 50 ohms, and I'm gonna put this to ground. And I'm gonna have, I could put this in my model, but I wanna really illustrate this point. This is gonna be a 50 ohm resistor, and this implies my 50 ohm input voltage source. Now it's not really, it's just a voltage source. I'm modeling it as a DC voltage source, but that doesn't really matter. Because I'm not actually gonna give it a voltage, I'm gonna give it an AC voltage of 2.
AC voltage or phase?
Yeah, I think I hit the wrong thing. AC amplitude of 2. There we go, AC2, you should have AC2. And then on this one, I'm gonna give it an AC1. And I'm gonna put down here an enormous resistor. I can put in, it knows, so if I do 1K, it knows 1K. If you do 1M, it doesn't understand case sensitivity. So 1M in Spice is 1 milliohm, which is useless. If you want a mega ohm, you type meg. You can also do 1E9, which is also a mega ohm. So I like doing 1E9, and then I'll connect you to ground. And then I'm gonna draw this way out here, because that's what we're gonna, that's our VNA. And if I label, just using F3 to make wires, I'm just gonna stick you out here. I can make a labeled net, this little box with the A around it. I'm gonna call him S11. And I can stick him right there. Now, whatever I connect to this in a 50 ohm system, I can tell you at what frequency maybe that's 50 ohms. Let's just, I'm just gonna make up some numbers, so this may not actually work as 50 ohms, but it'll drive the point home. Let's do a pi network, or a T network. Control R is rotate. So let's do these guys.
Control E is to mirror.
Yep. Clean this up a little bit. One thing you'll know about me is I'm a little OCD about organization. And let's put him on there as, I don't know, 100 ohms. And we're gonna do an AC sweep of this guy. And I'll explain to you what is going on with how this is a VNA. Okay, well first of all, I can't simulate this. You have to have values in for everything or it won't simulate. It doesn't know what L means. So let's just go 100 microhenries. And 100 microhenries. And 100 nanofarads, I don't know. I'm just making up numbers. Everything's 100. So, but before I run through this, this is giving us an amplitude of 2 through a 50 ohm resistor. So I'm automatically now saying I'm in a 50 ohm system. I'm gonna send that signal out, and it's going to it's gonna go out here and it's gonna bounce back some amplitude based on that 2. And I'm gonna measure it across this AC1 resistor, except it's negative here, so I'm gonna subtract a volt off, right?
Oh, is the AC1 resistor R2?
I'm giving it AC2 here through 50 ohms. So if this was a perfect 50 ohm system, I would have 1 volt right there, right?
Right.
And if all of this was just one single 50 ohm resistor, I would have 1 volt because it's a voltage divider between 50 and 50, right? Well, now it's a voltage divider between 50 and some other junk. So whatever bounces back towards my system here, let's say, we can draw, let's draw a rectangle and say, this is my VNA. So whatever bounces back into my VNA, I want to measure how much bounced back, right? That's my S11. And if I get real hand wavy and assume that there's no radiation, if I know how much bounced back and I know how much I sent, I also know how much got transmitted into this network. So I could say that this is S21. So I'm going to label it that. How much came from port 2 to port 2 from port 1? So if I run this, I'm going to do an AC sweep. Again, let's just do decade. I like doing 1001 points. It doesn't really matter what number you put there as long as it's sort of big. If you do too many points, it takes longer to simulate. So you'll play with it and figure that out real quick. Let's just go 10 hertz to 10 gigahertz. Huge sweep, because I don't actually know where this is going to land. So there's my simulation, and I can see I've got an S11. Oh, sorry, this is network 2. If you double click on a net. So I've got this response, which isn't really maybe that useful because it's so low frequency, but it's a high pass filter. No, it's a low pass filter, right, because it's S11. This is my low pass filter, and here's its frequency response, and it kicks on right about here. For S11, I really want this to be really low, and my S21, you can see now it looks like a low pass filter, and it falls off at some frequency. But my S11 is pretty bad. 9.5 is not the greatest pass band of reflection. Again, I just made up numbers. I wasn't thinking this was going to work. On the final, you're going to be doing this, and instead of saying this is a perfect 100 microhenry inductor, you're going to go find the manufacturer's model for that part, and it's going to account for all the parasitics in that part. If I right-click on this, I can say, hey, the peak current is this before the thing heats up and maybe becomes a fuse, and I've got some series resistance and parallel resistance and parasitic capacitance off of my winding coils. And you could put all these values in, and that would work also, but that gets real tedious when you start looking at dozens and hundreds of components. It's easier just to pull the model from the manufacturer's website. So that's what we're going to do later in the term. But I wanted to introduce you to SPICE because this is a rudimentary VNA.
Sorry, that's the word. You said V2 is AC source.
They're both AC sources.
Did you say they had different voltage? One was V, one was...
This one, V1 has AC2, has an amplitude of AC2.
Oh.
And V2 has an AC1. I don't know why it moved like that, but
Oh, that's what, okay.
that should go right there, like that. But
So AC as in 1 volt?
Yes.
Okay.
Yes. But only, that AC1 is only for an AC analysis. It has an amplitude of 1, because what AC does is it sweeps. I said sweep from 10 hertz to 10 gigahertz.
Wait, you said
It's always got an amplitude of 1 or 2.
Oh, sorry, amplitude, right.
So it's sweeping the frequency. That's what AC means. It only works in AC sweeps. In this
Oh, so
mode.
it's just sweeping whatever the hell, from what frequency to what frequency?
So it's the way you read this.
Oh.
My box is in my hand.
Sorry, am I the only-
F8 moves things.
There you go.
Am I the only one who has a little bit of that, who that looks a little bit blurry too?
No, it's totally blurry.
Okay.
The projectors aren't the greatest, and the lights are all on. The way to read this is an AC sweep, .AC. It's a decade sweep, 1,001 points per decade, starting at 10 hertz, ending at 10 gigahertz. If I really wanted to be super pedantic about this, I could write hertz in here. It doesn't, it understands, it knows. Do you always need to run it all the way to 10 gigahertz or all the way down to 10 hertz? No, it just depends on what your application is. When we build radios next term, you're going to be kind of hovered around the 1 to 2 megahertz range. So maybe you go down to like 100K to 10 meg or something, just so you have that right in the middle. It's up to you. A lot of the times in this class and next, I'm going to just give you the thing. There's no point in having you all build the same circuit over and over and over. I've already built it, I'll show you the file. What's nice about SPICE is that if I don't use any custom models, which I've tried not to do, you just have the model. And I can say, here's what I built, you simulate it and go play with it. I might give you something that doesn't work, and you have to go find out how to make it work. One of the things I will sort of get real picky about is I'll give you something and say, make this work, or find out how to make this, give this more gain, or impedance match this better, or whatever the command is. Assignment, I guess, I'm not going to command you. I want parts in realistic values. Does everybody know, have everybody heard of like E12 or E24 values? So when you buy it, there's no such thing as a